So yeah, I'm Joshua Hibschman. I work with my advisor, Haoqi Zhang, at the Northwestern Delta Lab. And I'm going to talk to you about Telescope today, specifically fine-tuned discovery of interactive web UI feature implementation. And I'd like to begin with a question that we get a lot in our research. Why learn from professional web UIs? It's a valid question. You've got a lot of great tutorials online. You can do HTML, you can learn JavaScript, you can learn CSS. And I'm not saying anything bad about these tutorials. I think they're great. I think people can learn a lot from them. But let's say for example you have a journalist, somebody that wants to write news articles and create their own website. They could learn HTML and JavaScript and spend a few weeks on it and learn it really well. But one day they might go to New York Times and see a really cool article called Snowfall, like this one that came out in 2012. It's a Pulitzer Prize-winning article about a blizzard that happened. It's got all these cool interactive features and weather. How do I do that? I'm a journalist. I spent 3 to 4 weeks learning HTML and JavaScript, and I have no idea where to begin. And this is kind of the feedback that we get a lot in our user class that we target. They've learned a lot of HTML, JavaScript, CSS, web development, but they see something cool on the web, something new that just came out that hasn't been taught before, and they want to know how to do it. And this is becoming more and more of a problem, so much so that Code Academy has developed its own curriculums called Build a Professional Website. And this one's for Airbnb, build the Airbnb homepage. And honestly, if we had this for every website out there, my research would be done. I'd be completely happy. Not really, we'd probably study it. But yeah, this is kind of the end goal that we have in mind. But if you want to create content like this, it's a little bit hard to author. There's a huge inspection burden. For that, if you crack open DevTools on New York Times Snowfall, you get 28,000 lines of JavaScript. What part of that's relevant? What part of it's not? And this was a theme that I talked about a little bit last year with our tool Unravel. We created this tool to go into web pages and show you the relevant code or relevant starting points to learn how the web page works. Think of it like a table of contents for a book. You can start at the table of contents, jump in, go find something, and then go back to the table of contents. The problem with that is just the back and forth interaction. You have to jump back and forth a lot. And we studied this, we launched an evaluation. We asked some software engineers to reverse engineer websites with and without Unravel. And I'd like to draw attention to this part right here. This is the time to reverse engineering without Unravel, and this is the time to reverse engineering with Unravel. And across 3 key sources, finding a first source, finding a second source, and then reaching that aha moment of how it works. And we left off with this difference that we found at the beginning, but finding that second source, there wasn't much of a difference, and then reaching that aha moment, there wasn't a difference either. Even in some cases, it took longer with Unravel. And that launched us on a journey of several prototypes. So we did a human-centered design iteration, prototyping a lot of techniques to try to get that time down for the rest of those, reach that aha moment, understand how websites work, professional websites. Our first prototype, we said, okay, let's finish the story with Unravel. Let's extract all the code and show it to them. Our users said, hey, show us the most relevant parts. We like this, it's cool, but we can't really learn from it yet. So we launched prototype 2, activity highlighting. Highlight parts of the code that were relevant. And they said, well, that's great to do at the end, but show us it happening live. So we did prototype 3, and we added live traces, and they said, okay, slow it down. JavaScript runs really fast. And all of these come together. We stepped back and assessed our design findings. Our users needed variable amounts of JavaScript at different time, personalized views for themselves where they could play sometimes, they could inspect sometimes, visual connections that link them from JavaScript to the HTML to the rendered DOM. And then finally, this one was kind of funny at the end. We developed so many prototypes that we just kept adding features to this bulky software and kind of Frankensteining it together. And pretty soon, users were just troubled with using the software and it became its own barrier. So we wanted to simplify it down and create a new interface. And the approach we settled on was kind of back to our book analogy. Instead of making a table of contents, pull out the relevant parts of the story for the user, put it together in a small condensed view, and then let them explore the rest. So in this journey, like Lord of the Rings, Bilbo Baggins has a ring, the wizard Gandalf arrives, Bilbo leaves, chapter 1 finished. Okay. If a user wants to come in here and see more of the story after this low barrier entry, click on this and drill down a little more. So what this looks like in practice, in code, say for our New York Times article again, you get a snippet of a map interaction with the scroll top and the animate weather together. And if you want to drill down more into it, you can later on. So this is what the whole interface looks like together. On the left, you have a website or a cool interaction that's happening, in this case a game. In the middle, you have HTML view, and on the right, you have JavaScript. And I'll show you how it works. Ready for a live demo. So I'm on a website, XKCD, like a pretty simple website, and it has just this one cool, like little drag effect in here without refreshing the page. Now let's see how that works. So from a Chrome extension, I'll launch the Telescope interface. So now as it's going, it's loading and some traces are coming in. What happened over here, without really seeing it very much, was Telescope swapped out the contents of this page with instrumented version of the page. And we're receiving traces and code in the view all at once. And at the beginning, mapping back to our user needs, we want to play and we want to inspect a little bit. So we have some startup code that ran when the page loaded. But let's say we want to see some that happens when you actually drag this map. Well, we come over here, and as the interface updates, I'll open it up a little more. There we go. Release the interface. There we go. As I constrain the time, I can move past the startup code that was running and just see the code that happened when the map was updated. And what this yielded was 50 lines of JavaScript with a function called, let me zoom in case you can't see it, with a function called update that moves some CSS. Now that's somewhat low barrier, 50 lines of code, that's not too much. Let's say if we wanted to drill down a little more. We could up the detail a little bit. Let's say we wanted to see what else was in there. Well, what started to appear was more of the jQuery internals. If you've ever wondered what happens in jQuery when it actually runs underneath, it's down there. We can open it up a little more and see the rest of the code. Now we have calls that ran in the background versus queried the DOM, which are the green ones, or ran in the background. So this amount of varied inspecting helps the user understand the difference between what queried the DOM, what didn't query the DOM, and what is essential and what is not essential. And if we click on one of these functions, it highlights elements of HTML that were manipulated, drawing a visual link between the JavaScript that ran, like this update function, to the HTML that was queried, to the actual website. I don't know if you can see. It's highlighting the elements of the website and drawing the HTML underneath, drawing the end-to-end connection. So that concludes our live demo, and I'll be demoing after this if you want to see some work on some other websites. So making this work, it wasn't straightforward. Websites don't really allow you to have this kind of interaction happen. And the technical challenges with making this work are you need to fully trace all front-end JavaScript on any public website, regardless or state of HTTPS. Now, in this chart, Unravel and Scry were contributions. They were tools that really helped you understand JavaScript that queried the DOM. Theseus broke it a little bit bigger, or made a bigger contribution. It allowed you to instrument all the JavaScript as well as whether or not it queried the DOM. And with Telescope, we wanted to make a contribution, make this work on the open web. And the way to do that was to overcome some technical blockers, such as overcome the fact that if you want to tap into JavaScript debug APIs, they're normally not cumulative. And we want the cumulative amount of traces to be able to understand the JavaScript. And to instrument all the JavaScript on the web page, we want to get around the browser's blocking of policies of script instrumentation or augmentation. And the way that we did that was with the sleight of hand technique. So let's say you have a HTML page, a simple HTML page. This is how Telescope swaps it out. A browser extension injects an agent into the page, and it steals the HTML out of the page and literally clears the DOM, and iterates through window keys on the DOM and resets them to their default state as well. Those contents are sent to an external server, our server. We instrument all the sources, HTML, JavaScript, and then return them back to the page where they're evaluated in a very strict order and loaded, and instrumentation can be set up. Once instrumentation is set up, we can run it through all the detail levels that I showed you with the green slider. And how the detail level is calculated is through 5 different levels. The green one is the DOM querying JavaScript. And as you saw before on that pie chart, that's the most important, or we agree that's the most important part to start looking at. But if you want to see the bigger part of the story, such as back-end calls, et cetera, you can go to higher levels of detail. So in this picture, this is all, let's say this is a site's JavaScript. This is the custom code that a user added, and then this is a library code they imported. For that site, just a few high-level methods will be highlighted in the green level. The first level, the default view that you want to show the learner as a low barrier to enter the code. And as they expand the detail levels, it brings in more. So this is, let's say you have a simple method that calls some data from the server. Let's bring that in with level 2. And then farther out, level 3, give you all active JavaScript for a site. Level 4, more, and level 5, all the code. So how did this work on all, or the websites that we tested on a larger scale? So we tested it on 7 very popular websites, very neat interactions, each with over 10,000 lines of code. 6 of those websites yielded an interaction technique with less than 150 lines of code as a starting point in Telescope. 7th site was less than 1,000 lines of code out of 30,000. And 150 lines was a significant goal for us, just to explain the high-level interaction that happens, because we feel that's low barrier enough. A sample snapshot of that is for the New York Times snowfall article I sent you. Just these 25 or so lines of code here show you what happens, how the article activates different videos that play as you scroll through the article. You have an initialize, and then you have some tracking code that tracks the user position, and then you just call this render player function. Another one is that dot-to-dot game I referenced earlier is when you connect the dots, what happens? It's actually, if you look at it, some very clever code. They just swap some classes and just swap some CSS attributes iteratively depending on the dot. It's reusable code. Which brings us to the user themes that we elicited during our exploratory study. So we noticed some differences between self-starters and student web developers, and we were excited that the self-starters were able to find class-based toggling and simple animation, which are very key steps to starting to understand web development, because so much of the web operates that way. Our student web developers found a little more complex techniques, such as event-driven design and MVC patterns. Some limitations with the study. There are some preventative web architecture techniques that make it a little harder to use, even if you can get good output from Telescope. When websites minify and process their HTML and CSS, it becomes harder to understand some of the attributes and queries in the DOM. Content security policies block script alteration, but that's not the end of the story, because you can actually remove content security policies. There's some performance overhead with Telescope. Before a website is instrumented on our end, there's a cache delay, somewhere 5 to 180 seconds. But after it's instrumented, it gets cached. There's some memory limits. And with our user classes, novices, very entry-level web programmers, without sufficient HTML and JavaScript knowledge, weren't able to extract a lot out of Telescope. And this is really the focus of our future work, because we'd like to cater to that entry-level learning gap as well with novices. And our plan for doing this is a social learning strategy where after using Telescope on various sites and pulling out small snapshots or fiddles, users can apply learner sourcing techniques to generate content around how to learn from those examples. And in voting and upvoting and downvoting can draw up better techniques. So thank you, and join with me in making more learning techniques out of the web.
Thank you, Josh. We are now opening the floor for questions. Any questions? One question I have is, how do you see Telescope being used to maybe learn, have novices understand JavaScript frameworks such as like AngularJS or React, things of that sort?
Yeah, that's a great question. And to cater to the novice level, we want a little more of a social platform. But for self-starters, somebody that's got a little more experience in HTML and JavaScript, the great part about Telescope is it pulls out high-level calls to frameworks that show the user how to start using those APIs. And in something like, let's see, like this slide. So up towards the top, you'd have this is like a high-level jQuery call right here. But the code to that is hidden. This shows you how to use the high-level calls in the API without showing you all the underlying logic. So if you wanted to teach a user Angular, you'd show them some selectors in the DOM, and then those would be connected to high-level Angular calls, like a scope update, for example.
Thank you. Any other questions? Oh, I saw two. Whoever gets the mic first.
Quick question, Michel Baudouin from Université Paris-Sud. Very nice work. I often have to dig through long JavaScript to understand what's going on. One thing I like to be able to do is to select a couple of DOM elements and see the code that affects that. You showed the other way around, where the code that you select also highlights the HTML. Could you go the other way around?
Yes. And so an example of that I didn't demo. If you click on the HTML, it shows you the converse, which is like this. What JavaScript queried this HTML? Yeah.
So I was wondering if you were doing anything additional to sort of breaking it down in terms of detail by, well, this is sort of what the user wrote, and this is jQuery. Like, are you doing sort of any code summarization, and what's the algorithm or logic behind that?
Right, that's a great question. And let's see, pull up the detail slide. So how the detail levels work, these are all user-driven right now. Not algorithmic, these weren't guesses. We just heard from our users, hey, I just need to separate out jQuery from the actual code that was called. Just show me the high-level calls. So how it works is, first we filter out if it's a recognized library, and right now we have about 30 supported libraries. If we recognize the code from that, it goes into a filter, and then we can filter it out and toggle it based on the display. The other way that this works is through the contributions of Theseus and Fondue from Joel Brandt, Tom Lieber's work, how it instruments the code. It catches it's like JavaScript or Java without garbage collection. We track every single function call, every single scope, and we have all that data. And we can, through a low-level call that calls the DOM, we can trace the call stack all the way up to a high-level call, like a jQuery call, for example, and then say, okay, we know that all of those low-level calls are part of the jQuery library. We're going to filter those out and only show you that top-level call, which is just like would be a $sign for jQuery, for example.